Hello everyone, in this video we are going to see a lesson electricity for grade 6, and this is the continuation of a previous video. And in previous video we have seen what are sources of electricity and how electricity was generated from them. And in this video we are going to see about the electric circuit and its types and what are conductors, insulator, all those things. First, let's see electric circuit. So electric circuit is a continuous or unbroken closed path along which the electric current flows. So look at this in this picture, and this is your continuous path, okay, in which the electric current flows from the positive terminal of a battery to a negative terminal. So the electric current flows from a positive terminal to the negative terminal. So the direction of flow of current is from positive terminal to negative terminal. And this is an example for your closed circuit, and this is an example for your open circuit. So here the switch is off. Switch is in open position, so current doesn't flows, and this is an example for your open circuit. Next, so what are the basic things which are present in an electric circuit? First one is a cell or a battery, and which is the source of electric current. And next is the connecting wires, so which helps to carry the current. And next, bulb, or it can be any device which consumes the electricity. And last is a key or a switch that may be connected anywhere in the circuit, so that we can stop or allow the flow of current at any point. So this is battery, connecting wires, a bulb, and switch. So next is the electric circuit. So it can there are two main classes of electric circuit: open circuit and closed circuit. So in an open circuit, the key is in open position, that is off condition, so the electricity will not flow through it. So look at this here. So the key is in a off position, so the electric current won't flow through it. So this is your off position. And in a closed circuit, the key is in a closed condition, and then the electricity will flow in the circuit, and in this condition the bulb will glow. So look at this video. In this video I have given you a electric circuit. So it shows both the closed and your, this is your closed condition, this is your closed one, and the electric current flows. And I have given you one more material here, that is your metal. There is a conducting material, and here there is a block. In the first one there is a block, that is a insulating material, so which doesn't allows the current to flow. And in the second picture, second one, you have a conducting material, and when the switch is on, it allows the current to flow and the bulb glows. And that's it. When the switch is on, the current will go and the bulb glows. That is your closed circuit. And when the switch is off, the current won't flow and the bulb doesn't glow. That is your open circuit. And next, so another classification of circuits. First one is a simple circuit, series circuit, and parallel circuit. A simple circuit is very simple. So we have a cell, key, bulb, and a connecting wire. And look at this picture. So everything will be connected. So that is a simple one. And next is a series circuit. A series circuit in which two or more bulbs will be connected, and it will be connected in series. So look at the picture here. So here the bulbs are connected in series. They are connected next to each other. Okay. And in the series circuit, if any one bulb doesn't glow, the other bulb also won't glow. So why is, so the from the battery the current flows through the first bulb and it glows, and the output of the first bulb becomes the input of the second bulb. So if there is a disconnect here, so if there is any disconnect here, the circuit is becomes incomplete, it becomes a open circuit, so current won't flow continuously, so the next one won't glow. Okay, so in a series circuit, if any one bulb gets damaged, the circuit is disconnected. So next one is a parallel circuit. So in parallel circuits, the bulbs are connected in parallel to each other. So look at here, here the bulbs are connected parallel to each other, and here if any one bulb doesn't glow also, other bulb will glow. Why is, the current starts flow from this positive sign of battery, and here it gets splits into two. The connecting wire itself, there the circuit gets splits into two, and each bulb gets a individual output. Okay, this has an individual output, and this gets an individual output, so it doesn't depends on each other. So if one bulb is damaged also, other bulb will glow. Okay, and because of this only, in our homes we use parallel circuit to connect all our electrical devices to the meter, so to the main. Next is the symbols of electric component. First one is a cell. Cell is a single unit. This is a symbol for it. We'll have a taller line and a shorter line. The taller line represents the positive sign, and the shorter one represents the negative sign. And next is the electrical bulb, and this is a symbol for electrical bulb. And next is a switch in on position. So in on position, it will be connected like this, and if it is in off position, so it will be lifted up. This line will be lifted up. This is your off. And next is your battery. So battery is a combination of two cells, two or more cells. So again we are repeating this cell unit twice. So this is a battery, and here also the taller one is your positive terminal and the shorter one is your negative terminal. And next is a connecting wire, which is represented by a single line. And next is an ammeter. So ammeter is an instrument which is used to measure the electric current flowing through a circuit. It is used to quantify quantize the electric current, to determine the quantity of electric current flowing through it. So it is always connected in series in the circuit. So next term is a conductor. So any material which allow electric charge to pass through it are called conductors. Example: copper, iron, aluminium, impure water, and earth. Next is the insulators. So any material which doesn't allow electric charge to flow through them are called insulators or non-conductors. Example: plastics, glass, wood, rubber, china clay, all those things. And in this picture, these insulators, you can see these things in your transformers. So next is a safety measure to safeguard a person from an electric shock. So when you come across this situation, so when someone got electric shock, how will you rescue them? First, what you have to do is you have to switch off the power supply and remove the connection from the switch and push him away using a non-conducting material. So you have to be very careful in pushing him. You should use only non-conducting material to touch him. And next, give him first aid and take him to the nearest healthcare center. So look at this picture. While they are removing the wire from the person, they are using a wooden stick, and they are fully protected. They are using a rubber glove, rubber boots, all those things. So while rescuing someone, you should be very careful. And next, you have to give your first aid before taking him to the primary health care. Next is the production of electricity from portage. So what are the materials required are copper plate, zinc plate, connecting wires, LED bulb, key, beaker and portage. So if the portage is older one, the amount of current you will get will be better. So what you have to do is, so you have to take a beaker and you have to fill off the beaker with the portage, and you have to place a copper plate and a zinc plate in series, and you have to connect the positive term of the LED bulb to the copper plate and negative terminal to the zinc plate. And what can you see is, so the electrons in the ions in the portage will keep on moving, and as they move, what happens is there is a flow of current in the circuit, and because of that the bulb glows. And if the portage is older, the concentration of ions will be more, and the intensity of glowing of the bulb will be maximum. Now next is, you can also produce electricity from lemon. So what are the materials needed? Zinc nail, copper rod, lemon, LED bulb, connecting wires. So instead of portage, you can use lemon also, or potato. So what you have to do is, you have to squeeze the lemon, and you have to pierce the iron nail to one end and insert a copper rod at another end. Connect the zinc nail to the negative terminal of the bulb and the copper to the positive one, and you can see the bulb glows, LED bulbs glows. If you don't have a LED also, you can connect it to the ammeter, so that very small change in the current also you can measure it using the ammeter device. Thank you. I will meet you in the next video. Thank you.